Problem 16. The letters PQR are entered into a 20 by 20 table according to the pattern shown below. How many PQRs will appear in a completed table? So one technique that I think people should learn here when you're doing problem solving, especially with large number of data and pattern solving identification, is to look for patterns within the pattern itself. Which what I mean by this is scaling down the table. The idea here is that if the pattern on a 20 by 20 grid exists, then the pattern that exists within a smaller scaled down version of it, such as a 10 by 10, should also hold true, right? Because scaling just simply reduces the size. And when I increase the size of a pattern, the pattern doesn't change. It's just bigger. So let's apply this concept into this question. And look here, we have a very neat 5 by 5 scaled down version already prepared for us. So let's just take advantage of it and not waste any more time making like a 10 by 10 when it's absolutely unnecessary. So let's consider a 5 by 5 right here. If I want to consider 5 by 5, let's just count it up. How many P's do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 P's. How many Q's do I have? I have 1, 2, 3, 4, 5, 6, 7. I have 7 Q's. How many R's do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 R's. Oh, I actually missed some Q's. This should be the Q's right here. Q and Q. Add 2, we get 9. What is the specific relationship you see between P, Q, and R? Well, if there's X number of P's, then there's X number of R's, and then there is X plus 1 number of Q's. Now, this is for a 5 by 5 pattern. Let's try to scale it down into another pattern to see what would happen. Let's scale it down to a 3 by 3. If I scale it down to a 3 by 3, what do I have? We have 3 P's, we have 3 Q's, we have 3 R's. Wait a minute, this pattern doesn't hold for all dimensions. Because now, if I have X P's, then I have the same number for each amount. So, which scalable factor do I call it to? Do I reduce it down to a 3 by 3 or do I reduce it down to a 5 by 5? Well, I'm given a 20 by 20, right? And intuition should hold that I should go down to the 5 by 5. Why? Because when we multiply this, we're scaling this down, right? If we're going to scale this down, we must multiply this by a fraction, 1 over n. But this n right here, right, it has to be 1 over n. It has to be in this format. Because that's the only way we scale up and down with a uniform factor rate. So to do this, what must this fraction be if I want to scale it down to 3 by 3? Well, this fraction must be a 3 by 3 over 20, and that is not scalable. Granted, it is scalable, right? But the pattern will be destroyed. The only way to maintain the pattern is where we have a 1 over n ratio, where n is a whole number. So in this case, if I want to go from a 20-20 to 5 by 5, the n is equal to 4. So this checks out. So we have a 20 by 20 scaled down 4 times to 5 by 5. And since we're scaling it down by a whole number, the ratio, the whole number, 1 over a whole number for that matter, the pattern that exists for the 20 by 20 must be preserved within 5 by 5 as well. It's not preserved within 3 by 3. Because remember, we're multiplying it by a over b, not 1 over b. Patterns only are conserved when I multiply by 1 over b. So therefore, the relationship is the number of p's must be equal to the number of r's, and the number of q's must be 1 greater than the number of p's. So let's look at our answer choices and see which one satisfies this condition. Well, obviously a is off, right? And let's see b. B is all even. Let's see, does that hold out? Q, right? The Q has to be the one more, so that's wrong. It has to be C. And let's check other ones. Well, Q is 1 less, so that's wrong, and then Q is 1 less again, so that's wrong. So your answer choice must be C.